All right. I think we have a little bit of time to just discuss about the concept of public key cryptography. So now that we have discussed about the number theory, I understand that always talking about number theory and algebra is not an easy thing, but I hope that with a lot of examples that I provide in every single slide, at least those numerical examples could help you to understand the definitions and the theories. We don't want to go through proof of them. If it was a crypto class, of course, we would be very interested to see the proof of everything. But this is applied cryptography. I tend to just stay away from the proof as long as they are unnecessary, and just get to the points and discuss more on the security proof of the crypto systems, not the theorems. But of course, if you are interested, you can always, there's a lot of, if you happen to find the textbook, I think you can find the PDF online, and there would be a lot more discussion and all the proofs on every theorem. So if you are very interested to learn about them. I think we have discussed in the last chapter, we had a lot of discussion together discussing about the symmetric key cryptography. So we said that, for this scheme to work, if we have two users, Alice and Bob, they have to somehow share a secret key. But now the problem would, if it was just Alice and Bob, everything was fine. They could, send and receive messages in encrypted format. But soon we got into a problem where we have more users. So if that is our intended user, we have n users in the system. So this user literally has to go and talk to every other user in the system. So this user has to talk to everybody else to share a different key with them. So let's say this is user 1, this is user 2, 3, all the way to n-1. Just use the same notation. And they will share key 1 with this user, then you would share, key 2 with this user, and then K3 with this user, and all the way to Kn-1. So every user in the system, they can have even different keys, but the point is every user has to keep n- keys or share n- key with everybody else, so that they would be able to do encryption and decryption. And as this n grows, you will see that this would become a little bit of tedious. Where is the safe place that you want to keep all these keys? And every time that you meet a friend or meet a person, you need to start to share a key with them. So that was the case where people started to discuss that, okay, this is somehow tedious. There should be a better way that the users could actually share keys. And that was the point where public key cryptography was born. So again, if you have the same users now, you can imagine, with the help of the public key cryptography, the concept is that every user has some key. So this user has K1, this one has K2, K3, K4, all the way to Kn. And every key Ki now is decomposed of two pieces, public key of user I, and then the secret key of this user I, right? So we said that by definition, everybody can share the public key, but they need to keep the secret key secret. And the public key works just like email address. So that means that there would be a database. Oh, what a database I designed. So there would be a DB, if you can imagine. So this is our DB, that we store all the public keys for storing PKs. So now if this user wants to talk to, let's say user 2, it doesn't have to meet this user before or share a key beforehand. It would just go and query this public database and asking that, what is the PK public key for user 2, right? And then the DB would return, the PK2 to this user, and then this user can start to just send his file, encrypt this message using PK2, whatever algorithm that is there, and just send this message directly to the user. I'm sorry, to user 2, not user 3, right? So this is the whole concept that the user doesn't have to maintain a table. Every time that the user they want to update their key, you have to go and keep up with that table, make sure that the table is always up to date. So the whole purpose of this public key cryptography is that this user would never need to actually keep any key, right? A public keys or share any key with anyone. Whenever you want to talk to someone, you just go to this DB, find the public key for that user, and then try to send your message in an encrypted format directly to that user. So what does this mean in the real world? Imagine in the real world that every user in the system, maybe this user 1 is you, and every other user is some website, let's say gmail.com, I don't know, Microsoft, or I don't know, Dropbox, or every other or university website that you want to log in and share key and communicate in a secret way. So there would be a database that you can go and look up and say that, hey, what is the secret certificate or the public key for google.com, and then you get it, and then you can start to communicate securely. So this is the whole purpose of the concept where the public key cryptography was born. The whole point was that the user doesn't need to maintain key, or it doesn't need to even meet every other user or a website or a server to share key. If you're talking about communication between the servers, and that's why because of the simplicity, the public key cryptography was born. We know that there is a lot more than this, and we found a lot of even more interesting applications for the public key cryptography. But I think this was the key point where the public key cryptography was born, to just have a better, efficient way and get rid of that local table for keeping the secret keys. All right, I think we are almost running out of time. I don't want to continue on this much longer, because the more we dive in, the more difficult it would be for the next session to continue with. So I'll just stop here. So I'll upload the final version for the previous chapter, the noted version, and hopefully you will have enough time to continue to study for those pages that we covered today, and then you will be ready for the exam next week. Any questions? Yeah, it should be this one. If it is a typist, I'm sorry. What did I put there? Yeah, I think it is. Oh yeah, I forgot to put it. It is x8 plus x4 plus x plus whatever. I'll update it very soon. Yeah, thank you for pointing that out. All right. If there's no more questions, we'll see you next week for your midterm.